data structures: arrays, one-dimensional, two-dimensional, and arrays of records. So, data structures are used for storing groups of data together in a variety of different formats. This storing of multiple attributes of data together is referred to as an array, and when coding an array, data is separated using commas and rows. So in this video, I'm going to try to illustrate these different types of data structures and arrays. And as said, when you code these into an actual system, the different data that we put into an array is separated by commas or rows. But I'm going to be illustrating it as blocks on the screen. But whenever you see these different blocks, okay, if they're on a row together, okay, they would be separated by commas. And when they're on a new row, they'd be in a new row in the actual code as well. So just trying to illustrate that aspect. But what I want to do here is try to visualize these different types of data structures. So firstly, we'll look at a one-dimensional array. Now, this is the simplest form of array, okay, and it's where the elements are stored in a linear sequence, okay? So we have one row of data side by side next to each other, and obviously they'd all be separated by commas for the array, all showing the different separate pieces of data in my array. Data is accessed individually by specifying the index value of each element stored in the array. So let's see what that looks like. So here is my array, and it's of the different seasons of the year, and all of them are indexed. So basically starting at 0, and then I've got 1, 2, and 3. So summer is 0, autumn is 1, winter is 2, and spring is 3. So if I want to look up something within my array now, I've called it season array because it is the different seasons of the year, and I want to know season array, okay, and obviously number 1 in season array. And as we can see there, that is obviously autumn. So I can recall that on screen, okay, by doing that reference. So obviously it's just a single line for a one-dimensional array, and everything is numeric in order the way it's indexed starting from 0. The next category that we'll look at is a two-dimensional array. And this is a data structure that contains a collections of cells. So it looks similar to a spreadsheet almost. Okay, and it's laid out in a two-dimensional grid. And what we mean by two-dimensional grid is it has an X and Y axis. So in this matrix type of format, it is tables and rows to make up a table. So because it's a table, we need an index from both the column and row in order to reference our items. So we can store items obviously in a similar way we did with one-dimensional, but now we have both an X and Y axis in that we can arrange it and semi-categorize it within our two-dimensional array so that things are easier to recall and obviously remember as well. So what we're looking at here is, here are my months of the year, and they're in columns based on their season. Now, obviously, I've got 3 by 4 as my row, but remember, I still start at 0. So I've got to get my references up. So I've got 0, 1, 2, and 3 going across my x-axis, and then 0, 1, and 2 going across my y-axis. So let's say I want to do a reference now, and this will be my month array, and I need to give a reference for both row and column. So I'm going to look at row 1, column 3, and that should return me October when I run it through my program. So that's a two-dimensional array. Okay, we've got columns and rows. We reference them as well through the indexed values, but we need to give both a row and column value in order to find a specific position within my array, okay, in order to return an actual value to me when I search through my array. But obviously, this can make things a lot more logical when organizing data. Obviously, more meaningful when I've got more data within my array as well, based on how I structure the array. Okay, so it's got a bit more capacity than I did have with a one-dimensional array where everything will be stored in one long row, and it might make easier for me to remember things based on this structure being used. The final data structure we'll look at is an array of records, and this stores records of related data similar to how data might be stored in a database. And by saying that, it means that we're bringing fields into it. We can actually name fields for each of my columns within an array of records. Because I'm using these fields, okay, in this format, I can reference them and use them to retrieve data from my array. So the records are still stored in sequence, but each row represents a complete individual record. So every row within this array is related. They're all one specific record, and my top row will be fields. So let's now once again look at an example. Here I have my data that I want to store about different months of the years. I've got the month name, the days, and the season which it occurs in. So they are my fields for this array of records. And then now each row is going to be a different whole record. So I've got my details on May. Its month name is May. It's got 31 days within it and it occurs in autumn. Then I've got June, 30 days and occurs in winter. And July, 31 days, occurs in winter. So based on the fields, I can use them to reference this data, but they still also need to be indexed for each record, similar to how they need a primary key when we actually do use it in a database. So still starting at 0 and then 1 and 2, okay, representing my 3 different months. So if I wanted to retrieve data from my array of records, it's going to be my month array. I say the row of the record which I want, so let's go with 0 here, and that's obviously the record of May. And if I specifically want to know the days in May, I write days after the record's indexed value, and then it should highlight and return to me 31. Okay, so I can actually incorporate my field names when referencing and trying to retrieve data in my searches. So I hope this video is giving you an understanding of data structures and how we use arrays to group data together, and then obviously can reference different pieces of data within our array. One dimensional just being pretty much a straight line of indexed data, which can be referenced using a single value. A two-dimensional array, which is made up of columns and rows, requiring two values to reference data, but obviously allows us to store it in a more logical state. And then an array of records, where we can bring fields into our array, allowing us to use them for referencing, but also including index values for different records within my program. So I hope this has clarified to you the different data structures and how they can all be used in meaningful ways for retrieving data from our programs.